So, factoring. Well, with this one, hopefully you recognize that 25 and 36 are both perfect squares, so this one is the difference of squares. So, it would be 5x plus 6, 5x minus 6, and then just double check that it worked. So we would get 25x squared. We get 6 times 6 negative, so that's the 36. And then the middle term, this would be 30x, and this one times this would be negative 30x. They cancel, which is why there's no x term there. So that was easy enough. With this one, oh boy. Let's see. So, first of all, can you divide anything out? A 3 will divide into this. A 3 will divide into this. You know that rule about divisible by 3? So you take the individual numbers, the individual digits, a 1 plus a 0 plus a 5 equals a 6. And since a 6 is divisible by 3, then 105 is divisible by 3. What about this one? A 6, 7, 8, 9. Yep, that's divisible by 3. So I can at least factor out a 3. That will make the work easier. So 7t squared. And then divisible by 3, well, a 3 will go into a 12 4 times. And into that 2 times, so it's 42 for the t. And then for the 105, let's see, 105 divisible by 3. Let's see, that's going to be 3 times, we'll give us a 9. Subtract that is 1. It worked. It's 35 times. Okay, now we need to try and factor this into two binomials with the 3 on the outside. So with a 7t squared, there's really no choice. It's got to be 7t times 7t. Let me get rid of that little square there. That's how the sausage is made. Okay, and then both of these signs are positive, so both of these signs have to be positive. And then for 35, probably 7 times 5. And if I put, here's a good time to use pencil. If I put a 5 here and a 7 here, will that work? So this would be 7t, this is 35, and 35 plus 7 is 42. So that does work. First guess, that was lucky. So if that wouldn't have worked, then I just would have switched, put the 5 over here, put the 7 over here, multiply it out, see if you got it right. You know, that's the way that it was done in beginning algebra, that's the way that it's done in intermediate, and in pre-calculus, and in calculus. Guess and check. Okay, so that works. Am I supposed to do anything else? Factor each polynomial completely. Oh, good thing I didn't turn off the camera. Did you notice? This is not factored completely. We could still factor out a 7. So if you factor out a 7 from this, it's going to have to go over here with the 3 and make a 21. So if you factor out the 7s, it leaves behind t plus 1. So that means at the very beginning I could have factored out a 21. Alright, well, got it done now.